So this is starting with confidence part B, section 4, solving the quadratic equations 2 using the completed square. This will help you with exercise 14. So as we discussed in the last video, a quadratic equation is a quadratic sum equal to 0, and we're finding x's, i.e. when the graph crosses the x-axis. And there are 3 methods to completing this, and we're today going to look at the third one, which is using the completed square form. So the completed square, when we're given x squared plus bx plus c, we end up using x plus a half b all squared minus a half b squared plus c, and this is the completed square form. So we're going to look at an example. Solve x squared plus 3x plus 1 equaling 0, giving your answers in the form ax equals a plus or minus b root c. And we have solved this one in the first video on solving quadratic equations, but we used using the quadratic formula, but we will still want to end up with the same answer. And so this is the answer we're going for here, minus 3 over 2 plus or minus a half of root 5. But instead we're going to use the completed square form. So first we need to get it into the form of the completed square. Firstly, I'm going to let a equal 1, b equal 3 and c equal 1, and I got these from here. A is 1, b is 3 and c is 1. And then we can write this into the completed square form, which is this one here. So x plus a half of b, which is 3 over 2 squared, minus 3 over 2 squared plus 1 is equal to 0. And we can tidy this up here. This is x plus 3 over 2 squared minus 9 over 4 plus 1, this is equals 0. And we can condense this down again. Minus 9 over 4, and plus 1 is also equal to 4 over 4, and this will help us when trying to condense these two together. X plus 3 over 2 minus 5 over 4 is 0. So now we have it in the form of the completed square, and we can start to manipulate it to find out what x is. So the first thing we do here is we pull this 5 over 4 over to the other side, giving us x plus 3 over 2 all squared is equal to 5 over 4. We can then square root both sides. Don't forget, when you square root, you need a plus or minus. We can then move this over to the other side as well, leaving us with what x equals. Over 4 minus 3 over 2. We can now look at what root 5 over 4 really is. We know from indices 1 that we can write this as root 5 over root 4. We can simplify this. This is root 5 over 2, and then we can use the sliding method from indices 2 to give us this. We can then rewrite this as a half of root 5. This will allow us to write this. This is x is a half of root 5 minus 3 over 2. If we pull back that example from the last video, we can see that this answer is identical, and hence we've solved the equation for x. We'll cover another example. Solve x squared minus x equals 0, and again in the same form. And again I'm going to write out what a is. A is 1, b is minus 1, and c is 0. And then get this into the completed square form. So x minus a half of b, this is minus a half, plus that's a minus a half. That is all squared. minus minus a half plus 0 is equal to 0. This gives us x minus a half squared minus, and we can square out this bracket, giving us a quarter, still equal to 0. Now we can reshuffle this and rearrange to get what x is, an x on its own. So x minus a half squared is equal to 1/4. And again we can square root both sides, so we can take away the square from here, and that's x minus a half plus or minus square root of 1/4. Don't forget that plus or minus. Again we can swing the half across, so x is equal to plus or minus root of a quarter plus 1/2. We can look at what to do with this root 1/4. We know from indices 1 that this is root 1 over root 4, and this is 1 over 2. So we now have that x is plus or minus 1 over 2 plus 1 over 2. So we've now got two options. So either x is plus 1/2 plus 1/2, or x is minus a half plus a half. So we can now say that x is either 1 or 0.